3449, which is considered to be the most hazardous condition when soaring in the vicinity of thunderstorms? A. Static electricity. B. Lightning. C. Wind shear and turbulence. The correct answer is C. When soaring in the vicinity of thunderstorms, the most hazardous condition to consider is wind shear and turbulence. Thunderstorms are associated with strong updrafts and downdrafts, as well as rapidly changing wind patterns. This can lead to significant wind shear, which is a sudden change in wind direction or speed over a short distance. Wind shear can occur horizontally, known as horizontal wind shear, or vertically, known as vertical wind shear. Wind shear can result in abrupt changes in airspeed and can cause the aircraft to experience rapid fluctuations in altitude. These sudden changes in wind direction and speed can be extremely hazardous for soaring pilots, as they can lead to loss of control, structural damage to the aircraft, or even a potential loss of lift. Turbulence, which is characterized by irregular and unpredictable airflow, is also commonly associated with thunderstorms. It can be severe near and within the thunderstorm cloud, making it challenging and dangerous for soaring pilots to maintain control and stability. While static electricity and lightning are also concerns during thunderstorms, wind shear and turbulence pose a more immediate and direct risk to the safety of the aircraft and pilot. 3426. Where does wind shear occur? A. Only at higher altitudes. B. Only at lower altitudes. C. At all altitudes, in all directions. The correct answer is C. Wind shear refers to the change in wind speed and/or direction over a given distance. It can occur at various altitudes and in different directions depending on the atmospheric conditions and factors such as terrain, weather systems, and local effects. At higher altitudes, wind shear can occur due to variations in the jet stream, frontal boundaries, or other upper-level atmospheric features. These can create significant horizontal wind shear that affects aircraft performance and stability. At lower altitudes, wind shear can occur due to factors such as friction near the surface, terrain variations, and local weather phenomena. This can result in both horizontal and vertical wind shear, affecting aircraft during takeoff, landing, and low-level flight. Wind shear can also occur in different directions, such as vertical wind shear where there is a change in wind speed or direction with altitude, or horizontal wind shear where there is a change in wind speed or direction along a horizontal plane. Due to its potential impact on aircraft operations and safety, wind shear is an important consideration for pilots and air traffic controllers. It is particularly relevant during takeoff, landing, and critical phases of flight. 3427. When may hazardous wind shear be expected? A. When stable air crosses a mountain barrier where it tends to flow in layers forming lenticular clouds. B. In areas of low-level temperature inversion, frontal zones, and clear air turbulence. C. Following frontal passage when stratocumulus clouds form indicating mechanical mixing. The correct answer is B. Hazardous wind shear may be expected in areas of low-level temperature inversion, frontal zones, and clear air turbulence. Let's break it down. Low-level temperature inversion. When a stable layer of air is trapped beneath an elevated warm layer, it can create a boundary where wind shear occurs. The contrasting wind speeds and directions between the two layers can lead to hazardous conditions. Frontal zones. Wind shear is commonly associated with the boundaries between air masses of different temperatures and densities. As a front passes through an area, the abrupt change in wind characteristics can result in hazardous wind shear. Clear air turbulence. Even in the absence of visible clouds, pockets of turbulent air can exist within the atmosphere. These areas of clear air turbulence can cause abrupt changes in wind speed and direction, posing a risk to aircraft. Overall, these atmospheric conditions create situations where wind shear is more likely to occur, and pilots need to exercise caution and be prepared for sudden changes in wind conditions when operating in these areas. 3428. A pilot can expect a wind shear zone in a temperature inversion whenever the wind speed at 2,000 to 4,000 feet above the surface is at least A. 10 knots, B. 15 knots, C. 25 knots. The correct answer is C. A temperature inversion occurs when the temperature increases with altitude instead of decreasing, creating a stable layer of air. Wind shear can be expected in a temperature inversion, and the strength of the wind shear is often related to the speed of the wind. In this case, the pilot can expect a wind shear zone in a temperature inversion when the wind speed at 2,000 to 4,000 feet above the surface is at least 25 knots. This indicates a significant difference in wind speed between the surface and the upper layers of the atmosphere, which can result in hazardous wind shear conditions for aircraft. It's important for pilots to be aware of wind shear conditions, especially in temperature inversions, as they can have a significant impact on aircraft performance and control. 2163. If a temperature inversion is encountered immediately after takeoff or during an approach to a landing, a potential hazard exists due to A. Wind shear, B. Strong surface winds, C. Strong convective currents. The correct answer is A. When a temperature inversion is encountered immediately after takeoff or during an approach to a landing, it can create a potential hazard in the form of wind shear. A temperature inversion is a layer of air where the temperature increases with altitude instead of decreasing as it normally would. This creates a change in wind direction and speed, which can be abrupt and unpredictable. Wind shear refers to a sudden change in wind speed and/or direction over a short distance. In the case of a temperature inversion, the wind shear can be particularly hazardous because it can occur very close to the ground. This means that aircraft taking off or landing may experience a rapid change in wind speed and direction, which can have a significant impact on their performance and control. Pilots need to be aware of the potential for wind shear when encountering a temperature inversion during takeoff or landing and take appropriate precautions to ensure the safety of the flight.